Hello, we are on 4.03 geometry notes today. And we're going to be talking about CPCTC, which stands for corresponding parts of congruent triangles are congruent. CPCTC. So every other letter is a C. And apparently Cami is having an outage today, so we're going to try this in a word. All right, so first, I'm going to give you, just as a little review here, if triangle ABC is congruent to triangle XYZ, then what can we conclude? Well, what do we know? What parts would be congruent? So for example, angle A would be congruent to what angle? Well, A is the first letter, so that would be congruent to angle X. Take a moment and find me the angles that are congruent to B and C, and then also please list out the segments congruent to segment AB, segment BC, and segment AC. So pause the video here and then fill those in. All right, so you should have had here B and angle Y because they're both the second letters. Angle C is congruent to angle Z. And then segment AB would be congruent to segment XY, your first two letters. These are your first two letters. Segment BC is congruent to segment YZ. And segment AC, first and last, would be congruent to segment XZ, the first and last. So this is, oops, can't do that in Word. Okay, we're just going to move that. So this is all, I'm sorry. Here we go. There's my little toolbar. So this is all by definition of congruent triangles, meaning if I know that two triangles are congruent to each other, I know that their corresponding angles will be congruent and that their corresponding sides will be congruent as well. So that's really important, but it often takes a while if you need to get those two triangles congruent. So we have now had the 5 different reasons of proving a triangle congruent. And now we can take those and we can say, once we know that they're congruent, we can pick out any of their corresponding parts and those will also be congruent. So whenever you're asked in a proof to prove a pair of segments or a pair of angles congruent, you want to first ask yourself, are they a part of two different triangles? So choose or find, depending on the problem, two triangles that contain the segments or angles that you're looking to prove congruent. Then you would need to prove those two triangles congruent. And again, you've got 5 shortcut ways of doing that. Instead of getting all the sides congruent to all the angles, we can use side, side, side. We can use side, angle, side. You could use angle, side, angle, angle, side, or right triangle, HL, or again, simply HL, as you'd see it on the Regents exam. So those are the 5 different ways. You should have those 5 different ways memorized and be able to tell me them. So if you think you can do it right now, pause the video and list out those 5 without looking. After we get those two triangles congruent, then you're going to use what we call CPCTC, which is corresponding parts of congruent triangles, to prove the segments or angles congruent. Because once we have the triangles congruent, we can say that all corresponding parts of congruent triangles are congruent. All right, so let's try this out in a proof. I'm actually gonna go onto the next page. So I have some room here. Sorry, some technical difficulties. It also is not letting me pause. I'm sorry. Here we go. Okay. Give me a few pages. So here's your proof. I want it all on one page, so I'm going to start here. Number 1. And now it's doing this thing it did to me when I used to use this last year. It just sometimes doesn't write all the letters that I actually write, like the little piece of the T. So segment MR and segment SR bisect each other at A. So I apologize if anything gets erased and I don't see it. And we want to prove that segment MS is parallel to segment TR. And here's your picture. ARTS. And statements. And reasons. So the first one is our given. Segment MT and segment SR bisect each other at A. All right, so first now let's go to our picture and mark that up. So I'm going to change colors here so we can see the new markings. So if MT and segment SR bisect each other at A, that means A is the midpoint of segment MT and A is the midpoint of segment SR. We don't know that those are the same exact lengths, so we don't know that they're congruent to each other. Now I want to prove that segment MS is parallel to segment TR. And as we've talked about before in proofs, it's often helpful to work backwards. So I'm going to ask myself, what would I need to know in order to get MS right here parallel to TR? So go to your boxes if you need to and ask yourself, what would I need in order to get these to be parallel to each other? Looking at your boxes, hopefully you're seeing that you've got 3 main ways that we use. The most popular ways are getting all interior angles congruent, corresponding angles congruent, or alternate exterior angles congruent. So I'm going to trace a transversal here, and I don't have any angles congruent to each other yet. So I want to think about what angles could I possibly get to be congruent to make those parallel lines? Well, it looks like if we want to be in these triangles that we should choose interiors. I see my Z pop out right here. It looks to me like maybe these 2 angles would be a good choice. Again, if you don't choose the right ones, we can always go back and do it a different way. So my goal here is to get angle M congruent to angle T. I am allowed to use one letter to describe those angles because there's no other angle at those 2 vertices. If there was, then I would need to use 3 letters, or I could put a number in those angles as well. So now again, I work backwards and say, how do I get angle M congruent to angle T? I know if I get those 2 angles congruent, I can get the 2 lines to be parallel to each other. So how do I get angle M congruent to angle T? Well, if I get the 2 triangles to be congruent to each other, then I know those are corresponding parts of those triangles. So if I can get triangle MAS congruent to triangle, and here you want to make sure you match them up correctly. So M went to A, that was 1 tick mark. So I want to go from T to A because that's 1 tick mark. And then from A to S is 2, from A to R is 2. So if I can get those two triangles to be congruent, then I can get a M and T, those two angles congruent to each other, which means I can get my lines to be parallel to each other if the alt-interior angles are congruent. So now I work back another step and say, how can I get those two triangles to be congruent? Well, I have here marked in orange my conclusion from my given, and looking at your picture, what else can you take from it that wasn't given? And hopefully you're looking at these vertical angles right here and say, okay, well, if I can get those vertical angles congruent, I have side, angle, side. So the angles included between the two sides. And that'll get me the triangles congruent, and then I can get these two by CPCTC, and then I can get the lines to be parallel. So let's write it out. First thing I want to do is conclude from my given. So I can say here that segment MA is congruent to segment AT. In the same step, I can say that segment SA is congruent to segment AR. And the reason for that would be definition of a segment bisector. Okay, so now I've concluded from both parts of my given here. And I want to try to get my triangles congruent by side, angle, side. So again, I like to write that out and mark as I go. So now I just got a pair of sides here and a pair of sides here. So I'm going to mark off that I got 2 pairs of sides. I still need my angle. Where am I getting that angle from? From my vertical angles right here. So for those, there is more than one angle at point A. So I need to name them with 3 letters, or you are welcome to put numbers in there as well. I'm just going to use the 3 letters. So angle MAS is congruent to angle TAR. And I'm talking about angles here, not triangles. And the reason is vertical angles are congruent. Okay, so now that gives me my third piece, which is my angles. So now I must have enough information to say my 2 triangles are congruent. So now I can say triangle MAS is congruent. So notice I'm talking about triangles now, not the angles. That's different. The angles are a part of the triangles. Triangles have 3 sides. And the reason is side, angle, side. Whenever you get triangles congruent, it's going to be one of those 5 reasons. Side, 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 angle, 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 side, or HL. Now I can say that angle M is congruent to angle T. And I want you to write it out. You can abbreviate, but as you're learning what this stands for, it's important that you write it and say it to yourself. So corresponding parts of congruent triangles. So if you take the corresponding parts, meaning the parts that match up, of congruent triangles, they are congruent. And then eventually I will be okay with you writing just CPCTC. I just want you to practice it for, at least this lesson and this homework until you're feeling okay. And now that I have those angles congruent, I can say that segment MS is parallel to segment TR, because if alternate interior angles are congruent, then the lines are parallel. So a lot of working backwards in this one, but all things you can do. It just has that little extra step of getting the corresponding parts of congruent triangles to be congruent. And these are like all the extra lines, I guess, that it takes out when it doesn't write them. I don't know. Who knows? Okay, next one. And we're just going to do 2 together today, and then you guys will have time to work on the rest of your stuff. on your practice problems. So your givens, we've got measure of angle 1 equal to measure of angle 2, measure of angle 3 equal to measure of angle 4. Also giving you that AB, so the length of that segment AB is equal to the length of AC. And I want you to prove, I'm going to guide you through this. So first I want you to prove that triangle ABD is congruent to triangle ACD. And then I want you to prove that angle 5 is congruent to angle 6. So you need to know what those angles are. So I'm going to draw you a picture. Again, not drawn to scale, definitely not drawn perfectly. Just for you to get an idea of where each letter is and what's going on in your picture. The only things that you can assume that are true are in your given. And I'm going to put in some numbers here. 1, 2, 3, 4, 5, 6. So those are all angles. Again, they're smaller angles. You can only use numbers to name angles that have one angle at that vertex. And get rid of all these little extra lines, or at least some of them. Sorry for those of you who go crazy when you see those extra ink marks. Tried to get them all. All right, so we've got statements. This one is a longer proof. So make sure you give yourself enough room. We'll start with our given. Measure of angle 1 equals measure of angle 2. Notice I've got M's here and I've got an equal sign as opposed to the congruency symbol and no M. And with our segments, we have no segment bar on top because we're saying the length is equal. Got that written out. I'm going to mark my picture now. So 1 is equal to 2 and 3 is equal to 4. And then AB has the same length as AC. So doesn't pop out maybe to you at first. So let's kind of look at where we're headed here. So I've got triangle ABD. I'm going to make green. And then I'm going to make my other triangle ACD gray. Okay, so I want to get those two triangles congruent to each other. One thing that hopefully is popping out at you is that they share this side AD. So I'm going to mark that with an X. So by reflexive property, I know that AD is congruent to itself. Now looking at my picture, I see I've got a side over here. AB and AC are each a side in the two triangles. Now I have a second pair of sides, which is AD equal to or congruent to itself. But I need something else. And I haven't used all my givens yet. I still have these two pairs of angles that are equal to each other. So looking at those, if I know 1 and 2 are equal and 3 and 4, what do you think that we could do there? So hopefully you're thinking, well, if I know, let's say 1 was 30 and 3 was 20. So 30 plus 20 would give me 50. And then 1 would still be 30, 4 would still be 20, 30 plus 20 would also be 50. So if I put in numbers there, it seems like these two would be the same. So if I take equal amounts like 1 and 2 and add the same amount to each of them, I should get equal. So like if you were in class, you saw I did the marker plus the paper clip. And whenever we do marker plus the paperclip or equals added to equals, give us equals, we should be talking about addition property of equality. So if we're adding together to get to the whole, so we have two parts, then we need to use angle addition and addition property of equality. So our 3-step process will allow us to get angle BAD. So our goal first is to get angle BAD congruent to angle CAD. Then I should be able to get my triangles congruent by side angle side. And then we will go from there to figure out how to get angle 5 congruent to angle 6. So first, let's work on that. All right, so first thing we're gonna do is I'm gonna change my segments to congruency so I can kind of just get those out of the way. So by def of congruency, make sure they have segment bars over there. We need congruent parts to make congruent triangles. So that gives me a pair of sides. Another one I want to get out of the way here is my reflexive property. So segment DA congruent to itself by reflexive. Again, that gives me another side, so I can mark that off. So now I just need to focus on getting those two angles congruent, these two right here. So I already have two sets of equals, so I can jump right into saying that measure of angle 1 plus the measure of angle 3 equals the measure of angle 2 plus the measure of angle 4, and that's our addition property of equality. All right, well, I need to get angle BAD congruent to angle CAD. So I need to get those up on the board because they're not there yet. Well, I know that measure of angle 1 plus the measure of angle 3 equals the measure of angle BAD. Likewise, I know the measure of angle 2 plus the measure of angle 4 equals the measure of angle CAD. And that is our angle addition postulate. Just means the sum of the parts equals the whole. Now I have those two angles up on the board. I want to get them equal before I can get them congruent. And I know measure of angle BAD equals 1 plus 3. So everywhere I see 1 plus 3, I can sub in a measure of angle BAD. So I'm just putting that in for this right here. Then I know measure of angle CAD equals the measure of 2 plus 4. So everywhere I see a 2 plus 4, I can put the measure of angle CAD. And that is by substitution. And again, I need congruent parts to make congruent triangles. So I'm just going to switch these back over to congruency. By definition of congruency, or again, you could say angles with equal measures are congruent. And that gives me my pair of angles, which is the last pair that I need in order to get my triangles congruent. So now I can say that triangle ABD is congruent to triangle ACD. And the reason, again, it's always going to be one of those 5 reasons, and we already said it because we got the 3 pairs of parts is side, angle, side. All right, so now I asked you to get angle 5 congruent to angle 6. So let's go back up and look at our picture here. Whoops, too far. So angle 5, is that a part of triangle ABD that I just got? And the answer would be no. ABD has 3 angles, right here, and right here. And 5 is none of those that I just traced. So then I might ask myself, well, what triangle is that a part of? And it's part of, so this is a new set of goals for this part B. It's a part of triangle XDA. So that's the black triangle right here. Make the other one black as well. So this one, angle 6, is a part of this triangle right here. Again, they share a side, and we know in these 2 triangles, we've got 3 and 4 are a part of those triangles. It's one of their 3 angles. So we know that angle 3 is congruent to angle 4 from our given. We need to switch that to congruency. We've got segment AD already from our parts, and we need a third part, though, in order to get those triangles congruent to each other. So here's where we might say, oh, well, look at this black triangle and compare it to the green triangle. We just got the green triangles congruent. Notice that the green and the black overlap a little bit. So if you look at where they overlap, you want to look at, do they overlap on a full side or a full angle? And over here, they don't overlap. They overlap on a full side, DA. So that's one place, but we already have that congruent to itself. they partially overlap on this side. The green side goes from D to B, the black only from D to X. So we wouldn't consider that sharing a full side of the triangle. So let's look at our angles then. We have angle BDA, we have angle 3, and we have angle 5. 3 shares a part of the angle, but again, it doesn't count if it's not a full angle or side. So it's only a part, so that doesn't help. 5 is not an angle in the green triangle. And angle BDA, now that is a full angle in the black triangle, and it's also a full angle in the green triangle. So I could get that congruent because I know that if in corresponding parts of congruent triangles are congruent, and that corresponds to this angle in our gray triangle. So now that I have the two triangles congruent, I can say that angle BDA is congruent to angle CDA. And the reason is by CPCTC. Again, let's just write that out while we're still learning it. Corresponding parts of congruent triangles are congruent. So now I'm looking to get a whole nother pair of triangles to be congruent. Let's work backwards again. So I'm trying to get angle 5 congruent to angle 6. And I know that angle 5 is a part of triangle DXA, and angle 6 is a part of triangle DYA. Again, make sure you match up those corresponding parts. If I can get these two triangles congruent, then I can get angle 5 congruent to angle 6. So then I say, how can I get those two triangles congruent? Well, that's what we were just talking about before. We already have a pair of angles, 3 and 4. We have reflexive property, which I'm going to mark here. And then I have this angle. So that would be angle, side, angle. So by angle, side, angle, I can get those congruent. Now let's go through our proof and see what we need and what we already have. So we have a pair of sides. So I'm doing this for the other triangle, different color, and I'm going to put boxes around them instead. So that gives me an angle. Now I need 3 and 4 to be congruent. So I'm going to jump down here and just change angle 3 congruent to angle 4 because I need congruent parts to make congruent triangles. And that's just definition of congruency. So that would give me, box that one, a pair of angles. And then I need my other pair of angles, which I just got by doing CPCTC. And that allows me to cross off the other angle. So now I have enough to say that triangle DXA is congruent to triangle DYA, one of your 5 reasons, and this one we already have up there is angle, side, angle. Once I have those two triangles congruent, now I can say that angle 5 would be congruent to angle 6 by CPCTC, which stands for corresponding parts of congruent triangles are congruent. Okay, so again, I know this is a long proof and there's a lot going on. So really try to go back through, make sure it makes sense to you, and try redoing it on your own as well would be really helpful. So again, you're getting your triangles congruent, use colors, different colors if that helps. And you got that, you had to get 1 plus 3 equal to 2 plus 4 to get those full angles congruent. And then we had the two triangles, the top triangle congruent by side, angle, side to the bottom triangle. Once we had those two triangles congruent, we could use CPCTC to get these two angles over here congruent to each other, which allowed us to get these two black triangles congruent by angle, side, angle. Once I had the two black triangles congruent, I could then get angle 5 congruent to angle 6 by CPCTC. And CPCTC stands for corresponding parts of congruent triangles are congruent. And that is it for the notes today. If you have any questions, please make sure you let me know. Pie out.